Over 2,600 light-years away from Earth sits Kepler-51, a highly active, violent young star constantly throwing off intense, chaotic energy. Orbiting very close to this chaotic center are 3 inner planets. At first glance, they look like standard gas giants, roughly the size of Saturn. But when astronomers measured their mass, they found these planets only weigh a few times as much as the Earth. That size-to-mass ratio puts them in a bizarre category called superpuff exoplanets. Their overall density is less than 1/10 of a gram per cubic centimeter. They are, quite literally, as lightweight and airy as cotton candy. To achieve that kind of density, their internal structure must be extreme. Astronomers assume they possess an impossibly tiny, lightweight solid core, which is buried deep under a massive, bloated envelope of wispy hydrogen and helium gas. A planet this inflated and fragile defies our standard rules of planetary formation. The physics we use to understand the universe dictate that a world this large and this light shouldn't be able to hold itself together. Our standard physical laws outline a clear process for making a gas giant. You need a cold, distant orbit and an incredibly dense, massive core with enough gravity to pull in and trap large amounts of gas. Kepler-51d breaks every part of that rule. It is the lowest density planet in its system, it lacks a massive core, and it orbits its star at roughly the same distance Venus orbits our Sun. That close proximity to a highly active star creates an immediate physical threat. The planet is under a constant, aggressive bombardment of high-speed stellar winds, capable of stripping an atmosphere completely away. Given its extreme lack of density and its dangerously close orbit, the physics suggest Kepler-51d's lightweight hydrogen and helium envelope should have been entirely blown out into space millions of years ago. Yet, it is still there. Kepler-51d is a fragile, cotton candy world surviving inside a cosmic leaf blower, presenting a strict scientific contradiction that astronomers urgently needed to explain. To solve the mystery, researchers turned to the most advanced observational tool we have, NASA's James Webb Space Telescope. Telescopes can't photograph these planets directly. Instead, astronomers rely on transit observation. When a planet crosses in front of its host star, scientists watch the starlight filter through the very edges of the planet's atmosphere from our perspective on Earth. Because molecules absorb specific wavelengths of light, they block particular colors while letting others pass through cleanly. This filtered light translates into a readable chemical fingerprint. By looking for distinct dips in a spectrum line, astronomers identify exactly which elements make up an alien atmosphere. Capturing this precise chemical fingerprint was the goal. If researchers figured out what Kepler-51d atmosphere was made of, they could determine how it formed and how it survives the aggressive stellar wind. But when the James Webb Space Telescope looked closely at Kepler-51d, it found absolutely nothing. The data showed no clear dips in specific wavelengths, leaving researchers entirely blind to the planet's chemical makeup. This frustrating result corroborated earlier observations made by the Hubble Space Telescope, which also stared at Kepler-51d and failed to find any clear chemical features. This data chart shows what James Webb actually recorded, a steady, linear trend, blocking more light steadily as wavelengths got longer. This linear trend rules out the theory of a giant ring system, because physical rings would block the light evenly across all wavelengths. With rings off the table, the linear block of light leaves only one explanation for the telescope's failure: a massive, impenetrable wall of atmospheric haze. Rather than a transparent envelope of gas, Kepler-51d is entirely enveloped in an incredibly thick, opaque smog of hydrocarbons, molecules of hydrogen and carbon. Visually and chemically, it's very similar to the featureless orange smog we see blanketing Saturn's largest moon, Titan. Except on Kepler-51d, the scale is mind-boggling. The layer of smog surrounding this planet is roughly the radius of the Earth. It is the thickest layer of haze we have ever found on any planet. This record-breaking haze layer likely acts as a physical shield, absorbing the star's energy and sheltering the planet's internal gases from the stellar winds. The haze might explain how the planet survives, but it completely obscures its origin story. Astronomers are left entirely blind as to whether Kepler-51d formed dangerously close to its star, or if it formed in the cold outer system and migrated inward over time. Kepler-51d provides physical proof of how limited our current scientific models of the universe really are. Before we began discovering exoplanets, all of our rules for planetary formation were based strictly on the relatively calm, orderly layout of our own solar system. The existence of a giant, lightweight, smog-covered world surviving in extreme heat proves that the universe routinely produces bizarre physical realities. We are only just beginning to decipher the mechanics of a wildly creative cosmos.